QIT is an established mining and manufacturing company with metallurgical facilities located in Sorel-Tracy, Quebec, on the south shore of the St. Lawrence River, and mining operations 600 miles downstream near the port of Havre St-Pierre. 3 million tons of ilmenite ore are extracted annually from QIT's open-pit mine and shipped by river to the Sorel-Tracy metallurgical complex. Here, QIT smelts the ilmenite ore to produce high-purity iron and a slag rich in titanium dioxide. The liquid iron from the smelting operation is used to produce 3 products: Sorel steel billets, Atomet ferrous powders, and high-purity Sorelmetal Pig Iron. The slag, known as Sorel slag, is used worldwide to produce white titanium dioxide pigment. This pigment provides excellent covering strength, brightness, and opaqueness to white paints, paper, plastics, and enamels. Atomet ferrous powders are produced by a wholly owned subsidiary of QIT, Quebec Metal Powders, and are used to make powder metallurgy parts for automobile and truck manufacturing. At Sorel-Tracy, the ore is beneficiated and mixed with coal for smelting in electric arc furnaces, producing 1.1 million tons of titanium slag and 900,000 tons of liquid iron annually. About half the liquid iron is transferred to the adjacent steel plant for conversion to steel billets using an oxygen-blown converter, ladle furnace, and a 4-strand continuous caster. The steel plant, completed in 1986 and continually updated, is designed to produce 500,000 tons of billets in carbon grades from 1006 to 1080, and in welding, low alloy, and aluminum-killed fine-grained steels. Most Sorel steel billets are rolled into high-quality wire rod and bar. Some billets are used directly as forging feedstock. The wire rod and bar produced is used to make quality products such as fasteners, welding rods, high-carbon tire bead, tire cord, and music wire, representing some of the most demanding applications for carbon steels, steels in which QIT is an industry leader. The steelmaking process begins with the arrival of ladles of liquid iron from the ore smelting furnaces. These are transferred into a 120-ton charging ladle, deslagged, and then charged to the converter. After blowdown, the steel is tapped and transported to the ladle furnace for further processing, chemistry adjustment, and temperature control. From here, the steel is carried across the casting aisle to the casting turret and the continuous casting operation. The casting process features ladle to tundish and tundish to mold shrouding, and double in-mold electromagnetic stirring. The caster features a 10-meter casting radius, curved molds, and multi-point unbending, and produces billets in the range of 120 millimeters to 160 millimeters in square cross-sections. Following billet casting, the billets are cut by torches in lengths up to 16 meters long, and then stamped automatically with the heat, strand, and billet sequence numbers. Full tracking of each billet and its associated steelmaking and casting history is therefore a standard feature of QIT practice. QIT's steelmaking and casting operations employ the latest computerized equipment and procedures, including automated alloy trimming, argon stirring, wire feeding of aluminum, carbon, and calcium silicon at the ladle treatment station, automatic tundish and mold level controls, and 3-zone fully instrumented secondary cooling. Computers monitor any deviation from standard operating practice and promote quality through individual billet tracking and selective inspection. QIT supports this approach to quality by a final inspection of shot blast billets according to a predetermined sampling pattern. QIT's philosophy behind the production of quality billets is not to rely on inspection, but to build into the production process the capability to obtain consistent quality by selecting the best equipment available and by developing a first-class workforce. This is achieved through active development work by engineers, training programs for steel plant employees, a continuous improvement program promoting employee participation, and the close support of a highly qualified team of research metallurgists who are backed by advanced analytical and metallurgical facilities. QIT's continuously cast billets are sold under the name Sorel Steel. The suitability of Sorel steel for critical applications, borne out by the wide range of products produced from Sorel steel billet, is achieved in part by a supply of liquid iron with a consistent low level of residuals deriving from QIT's ore deposit. As a result, Sorel steel is low in copper, molybdenum, tin, arsenic, lead, and other tramp elements that are difficult to control in scrap-sourced billets. Clean steelmaking practice, state-of-the-art continuous casting technology, and a highly trained and dedicated staff ensure that top-quality billets are produced, making Sorel steel billets most desirable for critical applications in the wire rod and special bar quality industries.